So the first thing I want to talk about, and we're going to just start talking while you guys get settled, is this ratio that we found, right? With these rowdy rodents. If we talk about knowing a scale factor, like they were enlarging this pennant, right, from 1 foot wide and 1.5 feet tall to 3 feet tall. So if we went from 1.5 feet tall to 3 feet tall, what was the scale factor there? Scale factor is 2, right? Now, what does that really mean when we start to actually buy products? Man, if my computer survives through your class, I'll be happy because it's just slowing down like crazy.
It's having a bad day.
It's having a bad day. I have updates to run. So if the scale factor is 3, what does that tell us about the scale factor of area? Or sorry, yeah, if the scale factor is 2, my bad, I just said it wrong.
4.
Why is it 4?
Wait, no, so if it's 2 times, if each side is 2 times bigger, or the dimensions are 2 times bigger, then it would be 4 times bigger.
Yeah, so whatever has happened to the perimeter, right? So whatever's happened to the perimeter, it has been multiplied by a scale factor of 2. For the area, what's going to happen to it is it's going to get multiplied by that scale factor squared.
Wait,
So if, hypothetically, your scale factor is, let's say, 3, what's your area scale factor going to be? 9. Whatever happens to the lengths, scale factor-wise, square it. That's what happens to the area. Area's scale factor is the linear scale factor squared.
Perimeter is the square factor times.
See, we figured it out yesterday. We just got confused because there were so many words.
The perimeter scale factor is the square root of the area's scale factor.
See,
Yes, okay.
Yes, okay. So, this is where we should have looked at. So if it's 100 times larger than the area, right? Area got 100 times the original. Well, then your linear scale factor is 10. Because your linear scale factor is the square root of the area scale factor. So you need to write that down to formalize it. Your linear scale factor is the square root of the area scale factor.
Linear is another word for perimeter.
Yes. Straight lines. Or honestly, could be curves, but we just have to know in linear relationship form. So then we have these awkward shapes, like this pond or whatever it is. Anytime you have an awkward shape, just describe it as a pond, because ponds form in any shape just based off water coming up. So this is a pond or something, and she's got a scale drawing of it, but we're looking at the real one, right? The enlargement. So if she enlarges the shape with a linear scale factor of 5, what's the area scale factor going to be?
Okay, so what?
that's it. Your time or 25.
Yeah, it's going to be times 25. Because if the linear scale factor is 5, the area scale factor is going to be times 25, and that will be a little under 500, so you said it's 400.
So I wrote 17 times 5 squared, which is about 425.
That's going to be a time pumpkin.
That's what we did, right? 17 times 4 to the 5.
It's going to be like a puddle.
Yeah, or it's in a fairy garden.
So
You've never made fairy gardens before?
I've never made one.
So cute. I like when I'm out hiking and I just find like a random fairy garden that like, I mean, it's cool. It's you like do something in nature, just leave it there.
I found fairy like brains before, and I always feel cool.
Yeah.
So I found one with dandelions in a perfect circle. I'm like, wow, that's magic.
I like the fairy gardens that look like they're like coming out of the tree, like they've somehow like glued a door to the tree or something. Really fun.
So it's always the original area times the scale factor.
So here, David, you answer this for me. What's the linear scale factor happening here? Hey, stop freaking yourself out. What's the linear scale factor?
You got
David, stop making random noises like you're somehow deflating. What is the scale factor from 10 to 40? 4. So then the area scale factor was/is. Don't even worry about the other numbers. 16, right? So if the linear scale factor is 4, the area scale factor was 16. But if we're going backwards, we take this area and we divide by 16. So our area of this original shape, or the smaller one, 41, I was about to say 656 divided by 16, 41 units squared. Does that make sense? Whatever the linear factor is, we square it for the area factor. So then same things happen even... Yep. Same thing happens going back and forth for fraction scale factors. So if we went from ABCD to the new shaded part of ABCD, our scale factor there would be 2 of 3, right, or 2/3. Yeah, so if we didn't realize or 3/2 if we're going up, right? If we went from the shaded region up to ABCD, same thing works with fractions. It just, the math gets funky. It feels weird. Biggest thing is make sure that when you power a fraction, when you exponent a fraction, you apply it to both pieces. Any issues on this one? I don't know how you accidentally measure your office twice as big as it is. But if he accidentally had measured his office twice as big as what it actually is, how is he going to need to reduce the area that he ordered by 4? Right? Because if he accidentally, that's like having measured this much when in reality your office was only that much. Right? Here's your 8 and your 12 versus your 16 and your 24. It makes sense when we think about it, right? If my lengths get doubled, I quadruple my area. But once we get into weirder numbers, yep, we would divide by 4.
Okay.
Make sense? So then here, scale factor is 3. So our area scale factor would be 9. So the smaller hexagon is a 1/9 of the bigger hexagon. And actually, guys, if this was to scale, any shape that tessellates, you can like do this and make it justify. Like even if we need to break up one of these, now this isn't to scale, but you could put other hexagons in here and you could actually fit 9 of these hexagons into this one if it was to scale. If. Giant if there. Right, so that was that lesson. No, there wasn't actually one of the, like we could. You could do it on your graph paper really easily actually. And any shape can tessellate, you just have to make the edges work together or you have to cut it apart. I don't know if I have any of the weird tessellations up here. There's a weird tessellation here hiding behind the clock with geese. You can actually tessellate geese flying 2 different directions. Yeah.
Wait,
I saw the one that was
No, so we're gonna try to skip 832, like all in. So your homework right now, literally what it said when you came in was your homework is. What did it say? What did it say? Anybody? What does this mean?
To be determined.
Yeah, aside from in Ohio, that means something different.
To be determined. BTTL.
But that's something you will see in Ohio.
Can you explain to me what it
That is the abbreviation for the Ohio State Marching Band.
Wait.
No joke. It is the gets a letter. The best darn band in the land.
Are we?
Yeah, seriously. The Ohio State Marching Band is like hands down. Now, that you ask somebody in Michigan or whatever else, they're gonna be like, well, our band's better. But so that's the abbreviation for the Ohio State Marching Band. But right now, all we care about is
It's based in the
this,
land of Ohio.
meaning to be determined. So if we can skip 832, we will not do that homework. So quickly moving through this, if we were going to try to enlarge a team photo, hey, this is a day where we're going to run. but I need you like with me, not having off-topic conversations. And we went down here to check which of these enlargements would be the correct ratio. Really quickly, check what. Don't just say just that. Check the other ones.
Well,
I know 8 by 10 would work. Will 7 by 9 work? How do we check it? Don't just say no.
Divide both of the numbers by their corresponding number. Like 7 divided by 4.
Okay, well, what's 7 divided by 4?
7/4.
Okay, 7/4. So 7 to 4, what do we check then? Is it
9/5, which is
equal
not,
to 9/5?
which is not.
How do you know it's not?
Because that is
What do you mean, because
simplified.
look?
They're already simplified. And
We know those fractions aren't the same.
we could do cross.
We could check with cross multiplication. So 7 times 5 is 35, 36. Crap, we're close. That's really close.
Something for 12 and 16.
Wait, does it work 12 and 16?
No, because 4 times 3 is 12, and then 5 times 3 is 15.
So 8 by 10. 8 by 10.
That's a 3. This is not quite. So the 8 by 10. Right? So this is why I think we're going to be able to skip this. Then,
This is basically the whole lesson.
essentially, if the original photo was 45 cents and you decide, original being 4 by 5, and you decide to get the 8 by 10, what do we do to our price?
Multiply by 4.
Multiply by 4. Because, David, piece it all together to us, our linear scale factor here, is, what's our linear scale factor? Times 2, meaning our area scale factor is 4.
Okay, I get it.
because that is the other scale factor squared. So our price would get multiplied by 4.
I get it.
$1.80, right? Because 45, 40 makes 90, then double 90. So we could do things like this, where we look at scale factors being fractions. Now I'm not going to make you do this. I just want you to like come with me on this journey. So make sure your brain is with me. If we go from small to big, which their table's upside down, we take like 5/3, right? Because we like scale factors bigger than 1. So I'm going to ignore what they have here. If we talk about ratio of sides being 5 to 3, then what is the ratio of perimeter? Oh, well, wait, that's the same. What about the area ratio? 25 ninths. Ooh, sorry, bad noise.
Because you square both common ones.
Yep. Yep.
Now here, this would make us flex some of our trig muscles, but I'm hoping that after you guys did the revisions on the last test, we don't have to flex those, because this 4 would line up with my hypotenuse here. So we first need to figure out that based off similar triangles.
30, 60, 90.
Yeah, so we can use 30, 60, 90 special triangle rules, but I'm trying to move very fast. Here, what is our linear? Actually, let's do some rapid fire. Liang, what's our linear scale factor here? 8. So Athena, what's our area scale factor? 64. So we know that for area, we'd be multiplying by 64. Find the area of this shape. We'll find the area of that shape.
Oh, he just
Any
she just
questions?
squared it. I just was like,
You just square that linear scale factor. Any
You
questions?
can math.
get it. I just am a little bit slow.
And that's like me and everything. This is a conversion for you to learn. No joke, it's just worth it to go ahead and get that learned. There are 2.54 centimeters in an inch. Because we are stuck in the American system, that's just one that's good to put in your memory. I'm just saying that as a general, this isn't part of this lesson, this is just my advice. There's also 1.6 gallons in every liter. You might as well learn that one too. So yes.
In our elementary school, like we all had to memorize like all the conversion factors.
What's the
That's
conversion
worth
factor
it.
from Celsius? I mean, from Fahrenheit.
That's like complicated.
Oh my gosh,
It's either
30
9/5
degrees
plus 32 or 5/9 minus, or I forget which.
So it's
But-
not an easy conversion, right?
Not normally. But what's nice is sometimes if you get a planner that has, and your planners have a lot of these in the back of them, we gave you most of the conversions, but even adult planners, so I'm trying to show you this.
I
Now
should
probably
get one
won't
of
be able
those
to find it.
conversion things and make bullet journal.
Anytime I leave the country.
Serious. Check it out. Like this is Ignore my passwords over on the screen. Look at the conversions. Like, literally, they give you lists of conversions. Would you like to hack into my retirement account?
I don't know how to
Or my EF travel account?
What's that?
It's how we go to, like, New York and
Yeah.
stuff. EF travel. So yeah, you're gonna end up having to do this nonsense using scale factors. So memorize some of those. Alright, actually help Jesse. Everybody takes 30 seconds. Answer this on your own, in your head. You do not really probably have to write anything. You don't know which one of you I'm randomly going to call on to justify if Jesse's right or not.
Well, hey, can I use
You
your
called on
calculator?
me.
No!
The first time, not the last time.
What? No, I'm not knowing you. I'm knowing Sammy. What are you trying to calculate?
That area.
What's 36 divided by 4?
Just get rid of the 0 and it's like
So you did it too.
I really want to say something about Be Army Strong since you're wearing a jacket that says U.S. Army complaining. I don't know.
Bro, when I get rid of my ad block, YouTube is just like...
Well, that's because,
the ad.
what's your age?
5.
No, here, what's your age?
13.
What's your gender?
Male.
Have you decided what you're doing post-high school yet?
Yes.
Like, you've made that choice. You've, signed
College?
to a college.
No.
No, you haven't yet, right? You think you know. You are a targeted audience.
I'll
A
go to
male
Canada.
teenager in middle school or high school, not like 17 yet though, because that's like they've probably already decided you're a targeted audience. That's on purpose. They know who you are.
They
Yes,
don't know me.
bots.
Yes,
They don't
I
know
do.
me. I'm not gonna...
Actually, male or female doesn't matter. Just any
No, I
high
heard
school
most of those
student.
ads too.
So our area scale factor, Sammy. Our area scale factor is 9.
I gave her that.
Sophia, our linear scale factor is. So, David, that tells us, is this right or wrong? Why?
Because it follows the perimeter linear scale factor equals the square root of the area scale factor.
Because it follows our rule.
Yeah.
It follows what we know. Area scaling will always be the square of linear scaling. I think you need that. Okay.
I can run to Canada.
Yeah.
Land a poutine and
It's probably their fault.
I think you died because you
So
called.
I can turn down my volume, but I can't turn him off, which is like. So, your teacher, right? Yours truly, I guess. I guess I enlarged this polygon.
Wow, what a
So the area of the similar polygon is 900 square centimeters. Do you ever realize
Wait.
how? Should I say this?
No, like math
So-
questions are like Bob bought like
No,
a
no.
truck full of cookies.
Stop. These aren't. I'm not getting on the. These are silly because they're not silly. But this, if you have your math brain turned on, and this is why I appreciate. What I'm saying is I appreciate getting to teach you guys, as opposed to if I was at a high school teaching math to normal sophomores, they may not connect this quickly. Our area starts at 100, and it goes to 900.
So it's
Man, this smells an awful lot like the problem we just did.
And you just pay attention to the hundreds place 1 to 9.
So what will happen to our perimeter scale factor? We'll keep going through.
I wonder what it could be.
Ooh, Athena, careful. I'm going to ask you that again without them talking. If our area scale factor is showing what it shows, what is our linear scale factor?
I got it.
We know you got it.
Maybe I got it.
So let me start you here. What's the area scale factor? 9. So what's the linear scale factor going to be? 3.
I did it
So
right.
the perimeter will take all of these values and triple.
Yeah, I did it.
So then we'd add them all up and triple it.
I did it.
Any questions there? Hey, look, that was that lesson. So, on to 841. Now you need a pencil out ready to write things down, probably. We have 20 minutes left. We can do this because you guys are awesome.
I know.
So, we already know that with a regular polygon of n sides, so a regular n-gon, there are certain rules that hold true. Like, it's perimeter is n times s, where the side length is s. Right? That's probably pretty silly easy. We could also talk about its area. We could also talk about its interior sum of angles. Right? We could talk about exterior angles. We could talk about central angles, right, from that center point.
We could make a whole conversation start.
We could make a whole conversation about these things. So, we have a pentagon here.
30-gon, isn't that like very similar?
Yeah, 30-gon would be
It's
a...
like almost circle, but not
Well, it
quite.
looks like a circle.
Ooh, I feel like 90-gon. That'd be like very
So,
similar to
who's ever heard of the unit circle?
Oh.
I brought it up, so hopefully the word at least sounds familiar. So the unit circle is a thing we use a lot in math. Actually, so much so that when I was at Columbus State with you guys, with our math counts team, there was a unit circle thing on the chalkboard. Remember, I geeked out about this. I was like, I want one.
Oh!
Yes,
oh,
that
that's
thing.
why.
That
I
is
was
used
totally
for unit
there.
circle
I know
work.
what you're talking about.
So here's the issue, though. Unit circle creates a radius of 1. That's why it's called the unit circle. 1 unit, right? So this is like a polygon that would fit perfectly on our unit circle, meaning if we made this our center, this polygon will be inscribed, right, giving us a radius of 1. So when we look at these different regular polygons with a radius of 1, I'm just telling you now, we're referencing that we're heading towards, and CPM probably doesn't want me to tell you this yet, but we're heading towards the unit circle. That's really where we're heading towards.
So why can't you get your own?
Oh, because it's a special chalkboard. Like, you literally, it's like a sticker on the chalkboard.
So you need like more. You could
And
put
you
it
just
over
print
there.
up paper and tape it.
I mean, but then you only have dry erase order. Like, I want a chalkboard with that. And you'll see why in a minute when we get to area arcs and sectors and
You could
everything.
put it, like, over
Guys,
there,
for
like,
Hudson's birthday, let's
have
get
space over there.
Yeah, I'm not.
So, I wonder, is there any sort of rule that we could create if every one of these polygons is going to have a radius of 1? Let's each of us pick one of these.
If they all have
Let's
a
actually-
radius-
Let's get real bold.
If they all have a radius of 1, that means they'll all be inscribed inside a unit.
Who wants the octagon?
I want the regular 180.
You got the 180. Okay, Sammy's got the 180.
I don't know what I do with it, but I got it.
You are going to find the area and the perimeter of your N-gon.
N-gon?
So your N is 180
Okay.
when it has a radius of 1. Okay? So Sammy is regular 180 gon. Come on, smart board.
Wait.
Who wants the 90 gon?
Me.
Liang. Who wants the 60 gon?
Wait, so we all know that all these
Athena. Who wants the 30 gon? Sophia.
I guess.
And you get the octagon. Or what do you actually tell me? What do you want?
Do
you want the 10 gon? Let's do 10 gon. Do the decagon.
Give me the 8.
David, do the 10 gon. Nope, do the 10 gon.
What about the 15
Can you
gon?
explain?
So, here's what each of you is doing. I don't care what triangle you pick, but I would pick an isosceles triangle and draw it on your paper.
Ooh.
I would also notate somewhere. I'm just going to keep talking, and if you don't hear it,
Did you say isosceles?
Yeah. That's not cool.
I'm just going to keep talking, and if you don't hear it, that's probably because you were talking. You then, based off what your N is, are going to figure out your vertex angle. I'm going to assume you said shoot, but it sounded like...
I'm gonna go ahead and get a calculator. I know what the vertex is. But
No,
like,
what?
So that hold on. You then, in any order you want, need to find these You already know
So they're equal.
these, right? You already know those.
Wait, we know
You need this to be able to get to your area. And if you're going to find your perimeter, you need this. Well, if you're going to find area, you need that too.
I'm still confused. I thought we were doing something about.
You're each doing the same thing, but with a different gon. So, like yours is a 10-gon.
Oh, sorry, so you're trying
Right?
to out.
So for your central angles, you'll take your 360 and divide it by your n. In your case, is 10, making 36. So I'm going to do this with David. Making this in here 18.
Oh, 18 and 18. I get it, because we split into 10 triangles, and then later we can do the multiplying thing. And so those are 70.
This is not ever, this is only David's.
Okay, wait. So I found the blue and the blue and the green angles. Now I just need to find the dotted line.
Do I know that that equals 1, the side length, or 1?
Yeah.
Oh, right, because the radius is.
Wait, so x just equals the sine of your.
I think I need a calculator. I need to do. Oh, wait, are you doing it? Wait, are you doing mine? Or are you doing
Well, when the hypotenuse is 1, hey, when the hypotenuse is 1, anything using the hypotenuse on bottom, which is the only place the hypotenuse ever shows up, that 1 isn't going to change anything. Check that you're in degrees. Just always check that
I
you're in
think
degrees.
I'm in degrees.
I'm in.
So,
I'm in degree, not degrees.
h equals sine of 72. Right? What'd you get for that, David? Sine of
I
72?
just got a calculator.
Well, I'm doing the work for you. You at least got a
I'm
calculator.
very sorry. Sine of 72 is 0.951.
You were... Oh, you're up here. 60 gone.
Did you not believe me, so you got your own calculator to check my work?
I couldn't really follow your numbers.
Oh.
I don't know if I did
We'll check each of yours to make sure that we're really comfortable with this process. Like, I will clone this page and we'll do each of yours real fast.
My perimeter is very close to pi.
Wait.
So wait, then area.
So,
Wait, so that means that the height is 0.95 feet, right?
Crap, I can't do area yet. I want to do base.
so, wait.
I do cosine.
Wait. Okay. Please. So with this, like I have opposite over.
What?
So what did I do? 1 divided by sine.
0.95 squared gets me 0.9.
I got an answer, but I did 1 divided by sine 89. That's not what I'm supposed to do.
Wait, now you're doing a cosine of 72.
That's what I do. Cause look, I just did look.
Don't worry, I'm only going to let each of you struggle for like 1 more minute.
Wait, what am I trying to find? The area?
Area and perimeter. Yep.
Well, oh wait, I need, so that's 0.99.
Opposite over. No.
Oh, I did something silly. I don't need this. Because I have half. Oh, well, this will be useful for perimeter.
Oh, I got that too. That means that I did it right.
So if this is half my base, I just do that times the height. Well, so really, cosine of 72 times sine of 72.
Ooh, wait.
So 0.2938858146 is the area of the entire triangle.
I really don't like this triangle
No, you don't.
anymore.
No, you don't. No, you don't. Leave it in your calculator.
And
How
also
many
5 by 10.
of these triangles do we have? 10. So this gets times 10, so 2.93, whatever. Yeah.
I think I figured out a pattern. Well, not really a pattern.
I think I did it. Oh, what have I done? Help, something happened.
Alright, let's step back and do a different N-gon.
Oh, I was good.
No, we have like 10 minutes, man.
You said we have 1 minute left.
What?
No,
No,
let us
that I was going to
struggle.
let you struggle.
Mr. Hudson, can I show you something that I've just been like doing? Or okay,
I mean,
so
yes.
well, I've just been like putting random things to do with the calculator, basically, like figuring out like the total like angle sum of a bunch of different like individual angles of like a bunch of different things, and like it each gets like incrementally closer to 180 degrees per angle, but it doesn't reach it, which I think has makes sense.
It gets incrementally closer to 180 degrees per
Like I did
angle.
a 20,000 gon, and each of its angles would have 179.982 degrees.
Yeah.
And then
Interesting.
the perimeter will just get closer and closer to 3.1415.
So, David and I were doing, what, the 10-gon? If we do this math over again... Yeah, let's do the 180-gon.
It's confusing.
So, in a 180-gon...
Wait a minute, I have a question. Mine's a 10 gone.
Yes.
It's a 180. Oh no, I was gonna make a connection.
So, that really means this peak angle is 2 degrees?
Yep.
Yeah, so then...
One.
It's not even degrees.
So this is 1 degree.
Yeah.
Wow.
And then
This is
89.
If it was a 200 gone, what would it
89
be?
degrees.
Huh.
So for the height, we're going to do sine of 89 equals h over 1, really. So that leads us to h is...
I got
Sine 89.
0.99984.
You said 2 point?
So it's 0.99. It's basically 0.99.
You said 9999. I'm not skeptical. I mean, essentially you're saying the hypotenuse is very, 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 very close to the height. That
Yeah.
makes sense because of 1 degree
That's
opening.
why I was a little confused, but like.
So then we could do cosine
And then, let me tell you what I got.
of 89 for this length.
I got 0.017.
So very small opening at the bottom because, well, 1 degree. Hinge theorem would tell us that'd be a small opening. That times this is going to be really small.
Yeah. I got the perimeter. I don't think I got the area.
Okay.
Did I tell you the perimeter?
No. I mean, if you want, sure. I don't know.
You don't want it.
No, you can tell me. I just don't know what we're doing with this.
I don't know.
Well, I thought you guys knew what we were doing.
As a 180 gun, it basically looks like a circle.
So, in a circle, we can kind of think of a circle like an infinite amount of polygons, right? That, or at least like that's kind of our argument, or like not an infinite amount of polygons, but a polygon with infinite sides, right? So if we actually, and if we had a big class, this would be a little bit easier. But if we actually do all of this data, here's what we come out to get. I want you guys to take a moment and like appreciate this without everyone talking to each other. Like just take a moment on your and start left to right. Don't actually here.
What do you mean left?
I'm gonna force it.
Shouldn't the area of perimeter be infinite? Because we don't know how many sides there are.
No, it can't be infinite. We're smarter than that. We
But
know
it's
things
just
can't
that
be infinite.
infinite.
So check it. If we had an equilateral triangle, area, perimeter, equilateral triangle, like a 3-gon, right? A 4-gon, right? A square, but with that radius of 1, so not side lengths 1, but a radius of 1. That's actually kind of interesting. You had an area of 2, so imagine a square with like 1 sticking out. Oh, the reason this happens, by the way, is because you get square root of 2. Let's just appreciate that for a moment. Where is a square on this? Oh, up there. If you imagine this is your square, and this is 1, and this is 1, what have you created? An isosceles special right triangle, right? So this edge being a 45, 45, 90, this ends up being radical 2 times 1, which is just radical 2, right? So radical 2 squared is 2. That's how we get the area of 2. So then check it. We keep moving forward. 2.6, a little bit bigger area, a little bit bigger area. But watch what happens. What is the area getting closer and closer and closer to? Pi. Right? We're getting closer. What is the perimeter getting closer to?
6.28, which is double pi. 2 pi.
This is where we derive area is pi times the radius squared.
Can we technically prove that that's the
We can.
equation for this?
And perimeter is, what's perimeter? Pi times d. Because think about it. If this is the square that we were working with, what's the distance all the way across? 2. So that would be the diameter, right? So if we are able to put a circle over top of this, notice how off my square is. I have all this extra space, all that extra space, all the, like, I'm way off.
Please pardon the interruption. Just a reminder for our students that live in the Kilbourne Middle School attendance area. We have dance tickets for Kilbourne Middle School for the dance this Friday, available in the Phoenix office through the end of the day today. Thank you.
Look at how much better this would be. Octagon. There's a lot more of our space taken up by the octagon. Right? So that's why, guys, the difference between 2 and 2.83 is just getting that incrementally closer to a circle. Right? So if this is really our data, then we can see, just based off the data, if we start rounding at hundredths places, which it told us to, but I didn't want us to for a little while, we get closer and closer to pi and closer to 2 pi. That's what we're supposed to be discovering here.
Wow.
Now, so you guys know my actual plan. My plan is by Friday to be done with 8, 3, 1, 2, and 3. so that Monday we're doing closure. Because actually, and you're my first class now, I'm out again on Monday. Sorry. I have
guess that
various appointments. It's that time of the year. So, yeah, it's best for you guys to be working on closure when I'm out, because obviously you know what you're doing. So that's the plan.